What does it mean for an entity to have free will? It is generally accepted that free will denotes the capacity to guide one's actions or make choices of action that are unpredictable and thus autonomous. In the case of beings with plastic neuronal connectomies, these computational structures engender random emergent features, such as sentience, that can reason about the world and then make top-down causal effects on the underlying substrate, which in turn creates the emergent supervenient consciousness in a recursive feedback loop. This recursive feedback loop is, in principle, deeply and inherently random. In other words, unpredictable. This is unpredictable strong emergence with a top-down causal effect, in other words, free will. The organism is still constrained by the laws of physics at the subvenient lower levels, but the randomness afforded by the Gödelian emergence creates an indeterministic unpredictability that gives the organism causal slack within which to actuate intentional free will. In this context, a natural question arises. At what point in scaling up a system of interacting components does it become conscious with free will? The signature of phase transitions seems to be an appropriate starting point in the analysis. There isn't some number, X, of neurons or statistical estimators that must be connected before consciousness arises. But there does appear to be a rather pronounced phase transition, not unlike a Bose-Einstein condensate, or the freezing of ice, or the coordination of spins in the Ising model that indicates a new stable attractor in the dynamical system. Once the dynamical system enters into the phase transition, the next higher-level Gödelian feature pops into place in a stable fashion. For example, the strong force appearing in the early universe, tornadoes or vortices, autocatalytic sets of self-organizing components, and consciousness are all examples of a phase transition in which the higher-level emergence randomly transforms the system into a novel stable attractor state that has an additional level of top-down causal structure. Neuroscientist Michael Gazzaniga has highlighted how our circumstances influence our desires, which in turn shape our actions, creating a feedback loop where actions determine subsequent circumstances. He argues that even if free will is an illusion and a criminal cannot fully control their behavior, society still benefits from imposing consequences for criminal actions. This is because such consequences help create a moral framework that guides behavior in the direction society deems desirable. In essence, we make a deliberate choice to structure the world in a way that encourages the kind of behavior we collectively value, even if individual free will is in question. Consider again the scenario of observing light from the quasar behind the Einstein cross. A conscious, sentient being, after careful deliberation, decided to observe the quasar's photons at some specific moment in time. In other words, this sentient being wanted to gaze into the night sky at this spectacular quasar. This means the conscious patterns in the activations of the neurons themselves have a causal efficacy that actuated muscles and tendons to bring about the observation on the specified date and time. And in so doing, the quantum state of those photons were collapsed from a superposition to a definite 8 billion light-year path around the gravity well of the intervening galaxy. All of this physical action, remember, thoughts and patterns are physical in accordance with Landauer's principle, generated entropy in the form of wave function decoherence and the associated expenditure of heat. This, in turn, drives further local decoherence, perpetuating the flow of entropy. At this scale of the universe, this is as free as one can be. A conscious act of observation influencing the quantum state of unfathomably distant photons, creating an intimate connection between thought and the unfolding of the cosmos.